Okay, let me see if I can help you with numbers 23 and 24, some basic proofs. In number 23, we are trying to prove that AB, given segment AC, AB is equal to BC. And it's also given that 2 times AB is equal to AC, meaning if I have two of these ABs, they're the same length as AC. Okay, so I want to prove, given 2AB is equal to AC, that AB is equal to BC. So let's do a two-column proof. We've got our given statement, our proof statement, we've got our diagram, and so let's start with the body of the proof. We'll start with what's given. I'm going to state what's given, that 2 times AB is equal to AC, and again, the reason why I'm stating that is because it's given. And then I'm going to break 2AB down to AB plus AB is equal to AC. All right, the distributive property justifies going from here to here. Okay, that's kind of, you normally don't look at the distributive property that way, but if we were going to go from this statement to this statement or this statement to this statement, we could justify that with the distributive property. Okay. Now, why do I want to separate it like that? AB plus AB is equal to AC. Well, if I take the segment addition postulate and state what may be obvious, that AB plus BC is equal to AC, I can do a little manipulation and come up with AB is equal to BC. Okay? Notice that in these two in these two statements I have a common value. AC is in this one and this one. So that means if A is equal to B and C is equal to B, okay, then A is equal to C. All right? So if that's true, then AB plus AB is equal to AB plus BC. That's the transitive property. If A equals B and B equals C, then A equals C. So we're using the transitive property to go to combine these two statements into this statement. Now, why did I want to do that? Okay, I wanted to do that because now I can notice I've got a common value on both sides of the equal sign, AB and AB. So if I subtract AB and AB, I'm left with AB is equal to BC. So the subtraction property of equality allows me to go from step 4 to step 5. Okay, so there's the order of thoughts there. Somehow you either have to recognize that you can use the transitive property to do this, or again, it just helps. Sometimes you just have to start with what's given and then write what you know and see how you can get to your desired conclusion. Again, remember, writing proofs, learning to write proofs is kind of like learning to ride a bicycle. You got to just keep trying and trying until you finally get it. All right, number 24. We want to show that the measure of angle 2 is equal to 118, given that the sum of the angles is 180, and the measure of angle 1 is equal to 62. So that shouldn't be too hard. We'll start with what's given, and those two statements are what are given, and then I know that the measure of angle 2 has to equal the measure of 180 minus the measure of angle 1. If I substitute the measure of angle 1 with 62, I have the measure of angle 2 is equal to 180 minus 62. Alright, and that gives us the measure of angle 2, which is 118 degrees. Okay, you might have done it a little bit differently. You might have said that the measure of angle 1 plus the measure of angle 2 is 180, and then substituted the measure of angle 1 with 62, and said that and the measure of angle 2 is equal to 180 minus 62. There's different ways you could have done that. Okay, and probably same thing with number 23.